Hello and welcome back. In the previous video, we talked about Apache Oozie and how to run a MapReduce job from Oozie. In this video, we're going to run a scoop job, a pig script, and more using Apache Oozie. So first, let us see how to run a scoop action in Oozie. So what we'll do is we will extract data from a MySQL database into HDFS. And from the previous video, we know that we need to configure the job.properties file, the workflow XML, and the libraries. Okay. So first, let us start with configuring the job.properties file. Since this is a scoop job and it runs a MapReduce job in the background to extract data into HDFS, we need to provide the path of the name node and the job tracker. And then we need to configure the path of the workflow definition XML file. Remember, we don't need to provide the input and the output directory properties like we had done in MapReduce action. Okay. Next, let us configure the workflow XML file. So you start with an XML file that has the start, end, kill, and action nodes, right? So you can use this as a kind of a template. First, I'll name this workflow as scoop-workflow so that I can easily identify my workflow. Then I'll start with the import to HDFS action. Okay, so I provide the import to HDFS name in the start to node, and then I'll provide the same name for my action. Okay, so this action is basically a scoop action, and this code basically defines the XML namespace that needs to be used. And in this case, we're using the scoop-action namespace. Okay, like in MapReduce, we first define the paths of the job tracker and the name node, and then lastly you define the scoop command that needs to be run using the command element. And then I'm going to use the prepare elements to prepare for my scoop import. So since scoop import runs a MapReduce job and it creates a new directory in HDFS, it doesn't like the existence of the directory into which it is supposed to write the data. So using the prepare statement, what I'm going to do is I'm going to remove the existing directory. Okay, and then I'm going to define the scoop command that is to be used to run my scoop import. So I'm going to use the command element and provide the import command. So here I'm doing a simple import of a table called as departments, and I have provided the connection details for my MySQL database. Okay. Note that I have not used the word scoop space import. If you had run the same command on the command line, you would say something like scoop import, but then the scoop action already knows that it's a scoop import, so you don't need to provide the scoop keyword here. So next, define the condition as to what happens on success and failure of the action. Okay. Now, I don't need to provide any custom jar files because scoop automatically creates the MapReduce jar files that is required to execute the job. So I don't have any custom jar file, so I don't need to create the lib directory in HDFS. Next, what we need to do is we need to create a workflow directory in HDFS, which is basically the same path that we would have used in the job.properties file, and then ensure that you move the required files into HDFS directory. In this case, just moving the workflow XML file should be good enough, and note that the name of the file has to be workflow.xml. So let us run this workflow and see what happens, right? Right, so let me take you to the directory which has the scoop data. Okay, so there is your scoop job.properties. Okay, you can see that I have configured my XML flow in HDFS using this path. Okay, then I have the workflow XML itself. Okay, it's basically the same thing that we just saw. Okay, now to ensure that I have already moved this data into HDFS, let's run this command, and then you can see that I have the workflow.xml as well as the scoop workflow.xml. This is not going to be used. Okay, so this is the XML file that's going to be used. Although I have the lib directory, it's basically empty. Okay, now let me run this workflow and see what happens. So Oozie job, I need to provide the path of the Oozie server. Okay, and I need to provide the path of my job.properties file, which is basically scoop job.properties, and then run. Okay, so now let's go ahead and check the status in the Oozie web console. Let me just go to active jobs. You can see that there's the scoop MR workflow running. Then you can see that there is an error. So let's see what the error is. So click on that particular line, it will take you to another window. So let me click on this link. Okay, you need to change the path here to provide the IP address. So you can see this is the link. So we'll go here, and then let's go to the task logs. Let's go to all. Okay, so you would need to change the IP address because you can see that there is no logs here. So let me go back. Okay, in some cases what happens is it would have deleted the logs on the task tracker. So what I did was I ran the job again and I was able to get to the task logs. So if I scroll all the way down, I will be able to find what would be an error, right? So you can see there are std error logs. You can see that there is a no class definition found error, org Apache scoop and scoop. Okay, now this is a clear indicator that the libraries required for scoop to run are not available. Okay, so whenever we come across such errors, there are a couple of options to fix this particular issue. So first, because the libraries are missing, so like we did for our MapReduce Oozie job, we can load all the required scoop jar files inside our lib directory on HDFS, right? We could do this and it would actually work. So in such a case, what Oozie will do is that it will take all the jar files that are present in the lib directory and automatically add them to the workflows class path when it's executed, so that those libraries are available during execution time. But what happens if we have a different Oozie job that also has a scoop action? So for that job to work, we'll have to copy the required scoop jar files to the lib directory of that workflow as well, right? But it does not make sense to load the same set of jar files in a different directory. It would have made sense if the jars were specific to each workflow, like the wordcount.jar file for our MapReduce action in the previous video. But these are all common jar files, so we should think of an alternative way to share common jar files between multiple Oozie workflows. The alternative for this is basically to use a property called as oozie.libpath in the job properties file. So you can specify all the directories that contain the required jar files separated by a comma against this particular property. So if you have 10 workflows and each of them use the same set of 4 jar files, instead of storing and maintaining 10 into 440 jar files in separate lib folders on HDFS, and remember those files again get replicated, right? So you're going to store a large set of files. Instead of that, you could just have 4 jar files in one location and then refer to them from your job.properties file. So this saves you from storing redundant files in HDFS. But here, now the drawback is that you still have to manually update the job.properties file with the path of the required file, which sometimes can be tedious, right? So there is another alternative to this solution, right? And that alternative is to use Oozie's ShareLib feature for allowing jars to be shared by different workflows. There are some actions, specifically distributed copy, streaming, pig, scoop, and hive, which require external jar files in order to run successfully. Now, like we discussed, we can either use these jar files by copying them into workflows lib or having to manually manage them through the oozie.lib path property in the properties file of each workflow. This would work, but then there is still some manual work required. So instead, if we use Oozie's ShareLib feature, right, we can overcome this issue. So what happens is, the ShareLib behaves very similar to oozie.lib path, and it works specifically for the actions we just described: distributed copy, streaming, pig, scoop, and hive. So once you deploy ShareLib, right, all of the jar files that are required get stored in HDFS in a particular folder, which we'll examine in a couple of minutes. And each of these actions has its own folder in HDFS, and it has its own jars. So this allows Oozie to use only the jars required for that particular action instead of every jar. And installing ShareLib is easy. So you just need to download the oozie-sharelib.gz file, unzip it, and then load the extracted directories into HDFS. Okay, but for our Cloudera cluster, this was already done by default. So in order to use ShareLib, we just need to specify the oozie.use.system.lib path is equal to true property in our job.properties file, and Oozie will then know that it need to include the jar files in the ShareLib with the necessary actions. Okay, so let's take a look at our ShareLib folder in HDFS. Okay, let me do fs minus okay, here we have Oozie user. Okay, so the ShareLib is in my Oozie directory in HDFS. Okay, share, and then lib. So you can see that it is ShareLib, and that's why it's called as ShareLib. And now you can see all the actions, right? So there's distributed copy, hive, MapReduce streaming, pig, and scoop, right? So all the required jar files for, say, scoop action are stored in this directory. And whenever we run a workflow, okay, that involves a scoop action, and we would have specified the particular property, which is oozie.use.system.lib path as true, it will come to this particular directory and take the required jar files and use it for the execution of that particular action. So what we'll do is we will edit our job.properties file to include this particular property, okay, and then execute our action again, right? So vi scoop job.properties, Okay, let me okay, so now let me go ahead and execute the job again. Okay, let me monitor the execution of this particular job. So as you can see, this particular job has executed successfully. Okay, so this is how you run a scoop action from Oozie. So with it a simple import, you could do pretty much anything you want, including running a scoop job itself. Okay, now let us see how to run a pig job from Oozie. Okay, so we have a simple pig script. So what we're going to do here is that we are going to, let's say, hypothetically speaking, let's say load the output of a MapReduce job into a relation and filter the relation to check if the data, if any of the words have occurred more than 100 times, and then store the output into a particular folder, right? So very simple pig script, and I'm going to store this as a .pig file. Okay, so next we'll configure our job.properties file, which is pretty much similar to the job.properties file we had for our scoop action. Okay, including the use of the system.libpath is equal to true property. Okay, then the workflow XML will basically use a pig action. So here we will configure the name node and the job tracker and also path of the pig script file. And since there is no custom libraries that I need to use, I'm not going to create the lib directory, and we already know that since share lib is already being set to use, any jar files that are required will be automatically picked up from that particular share lib folder. Okay, so let us run this workflow and see how it goes. Okay, let me go to the pig directory which has the required job.properties and the workflow XML. So you can see that this is my job.properties file, and then similarly the pig workflow.xml, again, that we just configured. Now let's take a quick look at the pig script itself. Okay, let me modify the output directory to point to the latest directory we used, and let me point to the output to a new directory so that it does not fail. Okay, now I will check if I have contents in my pig directory in HDFS. Since I modified the run pig script, I am going to remove this particular file, okay, and then put it into HDFS again. Okay, so now I have all the required files. I can go ahead and run my job. Let me provide path of the Oozie server and then path of my job.properties file using the config property here, and then run. Okay, so the pig workflow is running. Okay, as you can see, the pig script has run successfully here. Okay, you can go to HDFS and quickly check for the output. And you can see the Oozie pig output 123 directory is created. Okay, so this is how you run a pig script from Oozie. Okay, now let's move on and see how to run a shell command from a Oozie, right? So let us say I want to ensure that a directory is either present in HDFS or it's removed from HDFS before performing certain operations. I know that I can use the prepare element to in a particular action, like say map reduce action or pig action, to remove or add a directory, but I can run that from a shell command as well. So this is just to illustrate that particular feature. So you would need to first configure the job.properties file, which is the same that we've used for the pig and scoop action. Then we need to have a command which will basically create a directory in HDFS, right? And I'll store that as a shell script file, right? And then we'll configure the XML file, which basically now contains the shell action, which has the paths for the job tracker and the name node. And then we configure the command and the path of the file that needs to be run. Okay, so let's go ahead and see how this will actually work. Now let me go to the shell folder which has the files that I need. So first let me check this shell.sh script file. So here what I'm doing is I'm first creating a directory called newdir and then removing it and then creating another directory. So you can see how a series of shell commands get executed. Okay, and let me run this job file. Before that, let me ensure that I do not have any directory called as newdir in the Oozie folder, which I have used in the shell script. So I do not have a newdir folder, so I could go ahead and execute this shell script file. Okay, so to do that we use our standard command to run the Oozie. Okay, let me type that command, Oozie job minus run. So the expected output is basically there should be a directory called as newdir2. Okay, let me check. So you can see shell workflow is running. Okay, and you can see that it has run successfully. So let's go ahead and check the contents of Oozie directory and see if there is a newdir2. Okay, there is a newdir2, and so you can confirm that our action has run successfully. Now let's go ahead and see how to run a Hive script file now, right? Okay, so running a Hive script is very similar to running a shell command. Okay, so my idea is to create a Hive table. So what I'm going to do is first I'm going to configure the job.properties file, and then in a script file hivescript.hql, okay, I'm going to configure the command to create a table, okay, and store it as a script file. Okay, next I'm going to configure the workflow XML file, and here, just like how we are done for all the commands, provide the path of the job tracker and the name node, and provide the path of the script file that needs to run. So remember, the path of this file is relative to the workflow directory in HDFS. So just giving hivescript.hql indicates that this particular file is in the workflow directory. So let's say it is Oozie/hive in HDFS. Okay, and again there are no custom jar files. Since I'm using sharelib, I don't need to put in any jar files here, and also I don't have any custom jar files. So let's go ahead and run this file. Sorry, let's go ahead and run this workflow and see how that works. Okay, let me switch to the Hive directory where I have the files. So you have the job.properties file, you have the Hive script. Okay, so here you're creating a table called Oozie underscore test if it does not exist. And now let's go ahead and run the Oozie job. Okay, so only thing I have to change here is the job.properties name, and I can run it here. So it has initiated a job, and then we can go ahead and monitor the job in the Oozie web console. All right, so now let's go ahead and move on. Now, so far we have seen how the following Oozie actions work, right? So we saw how to run a MapReduce job, a pig script, a scoop import command, a shell command as well, and a Hive script, right? Now let's see how we can combine all of them in a single workflow and then run them either in sequence and or in parallel. So let's take a quick scenario, right? Let's say I want to import some data using scoop. So I'm going to have a scoop import action. But before we import some data, let's say I want to delete an existing directory into which scoop imports data. So for that, I can use a shell command, right? And then let's say I want to run a MapReduce job followed by a pig script, and then finally in the end I run a Hive job to perform some analysis. But let's say since the MapReduce job and the pig job does not have any dependency among each other, I decide to run both of them simultaneously like this. Of course, what these actions do in this example are totally unrelated, so this is just for the sake of illustration of how we can run multiple actions in the same workflow. Now, if I have to represent this as a direct acyclic graph, then it would be something like this, right? So it has a start node and the end node, and then in between you have the actions running in sequence or in parallel. But since there are two actions running in parallel, we use what we call as a fork node to split the processing into two paths. A fork node basically splits one path of execution into multiple concurrent paths of execution. And once the paths have been split, okay, we need to join the paths using a join node. And remember, a join node always waits until every concurrent execution path of the previous fork node has completed till before it proceeds to the next action. So here what we're doing is, after the scoop import using a fork node, we're telling that run the MapReduce job and the pig job in parallel, and after both of them have successfully completed, right, then using a join node and then taking the action or the control to the Hive action. Okay, so let us see how to create the workflow definition for this particular scenario. So here we have a high level workflow XML. It just contains the definitions and not the details, right? So the flow is something like this. So from the start nodes to attribute, right, it indicates that it has to start the shell action. Okay, and once the shell action is successfully run, it should then go to the scoop action, and once scoop is completed, right, it should then transition to the fork node, and within the fork node, right, the start attribute in the path elements, okay, in this node indicate the name of the workflow nodes that will be part of the concurrent execution paths, that is, which all actions will run in parallel. So in our case, as was the requirement, the MapReduce and the pig jobs will run in parallel. And once the MapReduce action is successfully completed, okay, the control is then sent to the joining node, right? So remember, we mentioned that only if both the execution paths or all the concurrent execution paths are complete, only then it will take us to the next action. So now if MapReduce job is completed, it will then send the control to the joining node, but then it will have to wait till the other concurrent path, which is the pig job, also completes. So after that has completed, okay, it will then go to the joining node, right? So the to attribute in this joining node will indicate which is the next action that it has to run, and in our example it is basically the hive action. Okay, so after the hive action is successfully run, it will then take us to the end node, and then it will end the workflow. Okay, so now that we have defined this workflow, let us configure the properties file as well, and it's pretty much straightforward, right? Because I need the path of the name node and the job tracker. I've provided that. I've provided the path of my workflow XML and also specified that I have to use share lib. And then since we have a MapReduce job, I would also need to provide the input and output directories of that MapReduce job as well, which is not illustrated here, but I have it in my job.properties file. And then I need to configure the libraries. So since I have a custom jar file in MapReduce, I am going to create a /lib directory in HDFS in my workflow directory, and then move the word_count.jar file there. Okay, and then we ensure that we move all the files that are required into the workflow directory in HDFS, and then finally run the workflow. So let's see how this works in action. Okay, now cd, right? So here you can see I have the hive script SQL, then I have the sh file, and then I have the pig file, and then I have the word_count.jar file, and then I have a workflow XML as well as the job.properties, right? I have taken care to move all of these into my workflow directory in HDFS, which is basically Oozie/multiple, right? Okay, there is a typo. Alright, so you can see that all the required files are moved, and then I also have the word_count.jar file as well. Okay, so now we are all set to run this job, and I'm going to use the standard Oozie command to run my workflow. Let me specify the job.properties path, and then let me run. Let me log in to my web console, and you can see that a workflow by name, putting it all together, is running. Okay, and you can see the DAG for this job here. So you can see that it starts with the start node, and then it goes to the shell action, which is currently running, and then you have a scoop action after the shell, and after scoop, remember we had a fork node and splitting the paths into pig action and a MapReduce action, and then after these have run, it uses a join node to join the paths and then start the hive action and finally end it. So this is the flow, right? So looks like there is an error in scoop. It's probably related to the directory which is already existing or something like that, right? But the idea is this, right? So you can run multiple actions in the same workflow using the workflow XML that we have just explained. Okay, so with that we come to the end of this video. We saw how to run various Oozie actions such as pig, hive, shell, and a scoop command, and also how to run all of it together. Thank you for watching and stay tuned.